we're going to take you through a quick introduction to where the project is, how it came about, the milling and fabrication process of the timber, and then we'll end up talking you through the finished building. So this is the building as it appears from the town oval where it's situated. It's a long veranda structure with the sort of 2 or 3 primary functional areas kind of hung off the back of the veranda. Let's use the right. So we began the project in November 2014. And for those of you in Europe, this is a kind of roundabout way via Google Earth of how you get to Western Australia. In this case, via Reunion Island, which happens to be just about dead opposite Perth on the other side of the Indian Ocean. This is the southwest corner of Western Australia. Capital city Perth, most isolated city in the world, and Pingelly down here about 200 kilometers southeast. In a zone area of the state known as the wheat belt. And these 3 aerial shots give you a sense of how the landscape changes through the 4 kind of recognized Western recognized seasons. So this is the gazetted town. This is the main highway running southeast through the town. And this, of course, is a winter shot where everything is beautifully green. And there it is in its wide brown land glory. And our site is up here on the upper edge of the town. There's actually a river that runs through here that eventually joins the Swan River at Perth. And the town, it's a tiny town like most of the towns in the wheat belt in Western Australia. And of course, it's suffered an exodus of population, as is pretty usual over the last 30 or 40 years. There are still some magnificent buildings there, but there's also a fair amount of abandonment and dilapidation. But there's nevertheless a kind of a real country aesthetic. The business of the town is wheat and sheep. And that really kind of gives you a sense of how the place operates through the seasons. Now, these are the concept diagrams, really beginning with the veranda edging the sports oval in the town, the 2 primary functional areas attached to the veranda, and then the entranceway emphasized, and the veranda kind of developed to accommodate other parts of the program. Building was intended to be naturally ventilated. The town doesn't have a lot of resources, so they can't afford to run a large facility. Whilst the climate here can be pretty extreme, we can get up to 40 degrees in the summer, and we can drop down below freezing in the winter. For most of the year, it's fairly benign. And naturally ventilating, certainly sports venues, is pretty acceptable. And that's the overall site plan. Of course, this is all existing, and the primary motivation for putting this building together from the Shire's point of view, from the town's point of view, was to bring a large number of small sporting clubs that had grown up in the town over the last 100 years, I guess, who all had their own facilities that were in various stages of disrepair, and put them into one larger facility that the Shire would maintain rather than leave it to the individual sporting clubs to maintain. So this is sort of gathering together a whole lot of separate facilities into one larger facility, and adding into it a money-earning element, if you like, in this function centre, which will eventually contribute to the overall economic development of the town.
Yeah, I think what's interesting about these projects is because the towns are all getting fairly stressed because of the young people getting attracted away from the town for city life. A lot of the farmers families are leaving and not coming back. The idea behind creating a centralised recreation centre and cultural facility, and this is the culture of sport, is that sport is the kind of cultural glue of these satellite communities. So Pingelly, Brookton, Wagen, Narrogin, these eastern wheatbelt towns all socialise and gather together around their various codes in sport, be it football in winter, hockey is coming online a lot, soccer, as well as the summer sports of cricket on the oval, lawn bowls, netball, basketball. So the whole lot is actually really core to allow this network of social clubs to actually generate contact and cultural prosperity amongst social groups within these towns. And I think the town of Pingelly wanted to flex themselves and to actually create a kind of a landmark sports facility and function centre that would attract people to Pingelly, as well as support their surrounding neighbours and friends.
The initial concepts, these drawings, which date from 2015, 2016, we proposed to the Shire that a prefabricated timber building would actually be an economic proposition for them, because there's a very substantial uplift in building costs as soon as you leave metropolitan Perth. The country area, or the rural Western Australia, has really depopulated to the extent that there is not a lot of substantial building industry outside of the city. So to build a facility of this kind, almost inevitably we're taking people from the city down there, which means accommodating people and a lot of transport and so on. So a building which spent as short a time on site as possible seemed to be a good option. And of course, along with that proposal came a number of items or issues, if you like, to support the idea of a timber building, as well as the problematic questions, if you like, that arise apparently from building in timber. I would point out that while Western Australia began building in timber in the early days of settlement in the 1820s through to the end of the 19th century, we've lost the knack in the last 50 years. So it's only really just coming back online again. One of the issues, of course, is termites. We have some particularly voracious termites over here, which, excuse me, frightens everybody. Maintenance is something that frightens everybody. And I would say that maintenance probably falls into the band of almost fake news. Durability, again, fake news, but still something that worries people. Fire, we could also say that's fake news, but it's something that you have to design for and be careful of. Cost. Cost really is still being worked out. We are not a sophisticated enough industry yet to be able to confidently say that we can build in timber more cheaply, more economically than we can in conventional materials. But this building actually witnesses the fact that we can. And the other thing was there's no precedence over here. So trying to persuade clients that this is a good thing to do, we actually had to take them to Eastern Australia on a tour of similar scale buildings to see what was possible. And then on the other side, of course, sustainability, the speed on site, labor cost saving, durability, qualitative benefits, simplification of trades on site, and again, sustainability. It's inarguable.
So this is an aerial view of the facility. In the foreground on the right, you can see the playing fields. In the little corner, this is part of an ageing in place rejuvenation of this oval site. So there's a small health centre that's been built on the corner. Behind that are some ageing in place units, which are independent living units, which are platinum star. There's a swimming pool on the right there. And then the whole site falls diagonally from southeast to northwest. So there's a fairly significant groundwater movement because the hill is actually basically a rock hill. the water moves through the oval and it actually sort of moves underground past our building. So controlling water and groundwater movement was really important to preserve the floor space and make sure that's dry and well vented. So we'll talk about that a little later.
Just running through the overall project a little here on the plan. This is the function centre, probably the most complicated or complex set of spaces in the building. The covered multi-sport hall with change rooms and so on here that feed back out onto the oval and into the hall, and then a series of smaller club facilities down here and storage spaces. This is the kind of main entrance into the complex from the town, and it acts as a kind of outdoor foyer for the whole complex, as the veranda acts as the kind of grandstand on the eastern side here to the bowls, lawn bowls, greens, and here out onto the main oval, and kiddie zone around the back here. Now, we have a small plantation of yellow stringy bark, Eucalyptus mullerania, in Western Australia, and we were able to purchase 1,000 tons of this timber to use for cladding, decking, interior paneling, and flooring. Yes, that's right, the other thing. So we had this cut and bespoke milled, if you like, to the sizes that we needed for the job. And because we were milling it specifically to what we needed, we were able to get a much better recovery out of it than you would normally get out of hardwood logs that are cut to a sort of standard set of commercial sizes. The longest logs we were handling here are 8.5 meters. That gave us a little bit of leeway. The longest pieces single pieces we needed were just over 6 meters, 6.5 meters. Slabbed, stacked, air dried for as long as we could afford to air dry them, and then kiln dried. The other part of the story, of course, is the structural element. Now, the building was designed in rhinoceros, in 3D from the beginning. And the final model, which this drawing is a snap of, is actually exactly what was built. So every element that's in this drawing is in the final building, in the structure of the final building. So our model then interfaces directly with the CADWorks model that the fabrication engineer is working from, and processed through these amazing pieces of machinery, Hundiger K2, to shape and form the various elements that we needed for the building. The K2 works to sort of an absolute precision, and I guess one of the things that is quite surprising about this process is that you designed effectively to zero tolerance. You build tolerance in for the assembly process, not in the milling process. And using, this is all radiator-based LVL, very stable, very consistent. So we're able to actually get that level of precision that we need. These are the sorts of elements that are coming out of that. So on the left here, there's the floor, the structural deck sample, so the bearers and the joists which drop into a mortise and tenon, dovetail mortise and tenon, so no mechanical fixings in the floor deck. these two pieces on the right are actually the cross bracing, the structural bracing for the main sports hall, which you'll see later on in the finished slides. So more of that finished milling process. You can see the kind of precision with which these pieces are cut out. These stacked elements down here are cassettes that we made up for the ceiling and wall panels of the sports hall. Again, everything made up in little flat packs and eventually lifted into position, and stacks of bearers down here waiting in the factory to be shipped off.
One of the key things with this is that the assembly and the production and the packing, there was 26 truckloads of timber that came across from Victoria, from Timber Builds Yard in Victoria to Pingelly, and each container that arrived was exactly the right equipment, the right pieces for that stage of the build. So the builders would then take out those components, follow Timber Build's instruction sheet, which is part of the working drawings, and then assemble each of the elements of the building. So everything was there at the time, and everything went together if they followed the instructions.
To the point where the pieces, the top pieces that you took out of the pack are the first pieces that you need to put together. So as you get to the bottom of the pack, you've assembled whatever it is that happens to be on that truck for assembly. So the really fantastic thing about the way Timber Built went about this project was that they literally made it foolproof, I could say, for the process from leaving their factory through to assembly. This, I guess, is one of the important slides that we wanted to talk about in relation to the difference between something, the term mass timber that's bandied around a great deal at the moment, and a lightweight engineered structure. What you see lying on the ground there is actually one of the columns, one half of one of the columns for the sports hall. These columns are 8.5 meters tall, and they're 1 meter wide. That width is determined by the knuckle dimension. We kept them, they could have tapered down to 300 or 400. We decided to keep them straight because it works better within the overall structure spatially to keep them in this way. But you can see here that there's very, very little timber in that column, and that's I think the key to one of the points that we really wanted to make about this kind of construction.
I think it's that philosophy that, for those of us who are boffins and, follow Bucky Fuller and Cedric Price, how much does your building weigh? And
yep.
Just because you can make a building out of heaps and heaps of, say, mass timber like CLT, it's still, the philosophy should be, how light can we make it? How much can we stretch this material? And the sustainable use of timber is to actually stretch it and build much more stuff with the same amount of cubic meterage, rather than lock it up in smaller buildings.
And we know that there's a fascinating graph which I don't have with me at the moment. It shows the gradual decline in the use of structural timber from the end of the 18th century through to 2004, when engineered timbers began to be readily available and understood as a significant player in the construction industry worldwide. And then that graph just goes almost vertical over the next decade. So already in Western Australia, we're consuming timber at a greater rate than we're planting it. We're going to have a hole in our availability coming up not too far into the future. And this is a real concern, I think, particularly with this sort of the popularity of, let's just make a big slab out of it and cut a piece out of the slab. So for us, the minimisation of the use of the resource is a really important factor. So these are those portals when they're assembled. It's a 28.5 meter span made up in 3 parts, primarily for transport purposes. The rafter sits on the column. It's located in 3 little stainless steel pins, dropped in by crane, and then these big bolts drop through the sleeves and tightened up to hold it down. Whoops, sorry. That gives you a slightly more detailed view of that assembly with the 4 bolts here, the locating pins, and the rafters, and the whoops, the base connection into the plinth that we'll show you, or you can actually see them on this slide. These are this is the amount of concrete that's in the building. Very, very little. Suspended floor, as Finn was talking about, the being this kind of drift of water across the site. And whilst we've collected a lot of it along the perimeter of the building, there's always a danger that some of it's going to run through, so it runs underneath.
I think the other thing is that each one of those concrete stumps or footings is treated with a termite barrier. So there's a physical termite barrier. We used Home Guard from FMC as a membrane, and we also used a Home Guard termicide impregnated paint around the tops of those stumps to stop the termites getting up there into the building. And obviously all the pine is H2 treated, H2S treated, yeah, for all the radiator LVL.
Yeah, that's the treatment in the glue line rather than the surface treatment. Now, I guess one of the other things I wanted to point out was the way in which this building went together, and this one in particular, because this is probably the clearest example. So we began erecting the columns at 7:30, I think, in the morning, and by 5 o'clock, 5:30 in the afternoon, we had all the columns up, about half of the upper wall panels, which you can see laid down over here, in position, and the 4 main roof assemblies in place. Obviously, the intermediate ones have to go up by scissor lift because they're sharing the rafter. So they're assembled on the ground, and then one big crane with a big spreader just lifts them into position. Putting the first one in probably took about 4 hours, 4 or 5 hours maybe, and the others went in very quickly after that when the guys had worked out how to do it. I should point out that the people that are putting this together had never put one of these buildings together before. They were pretty psyched with the whole thing. Slightly clearer image there. These are the wall sections I was talking about. Do you want to talk about the footing?
Yeah, so you can see the footing grid layout underneath the building. There's obviously some primary of larger footings which pick up portal frames, and then the smaller ones where you're just picking up joists and beams. That's where the joists. And then running along the edge of the oval, you can see a retaining wall, which is a limestone block, mass retaining wall with textile fabric and an agricultural drain on the oval side of that, try and pick up that water. But it really a really simple site. The site has been filled with sand, which was donated by the local farmers who all bought out sand off their various fill sites. So it's kind of a community-built contribution on that edge. We'll try and move along a little bit quicker because I can see we're running short of time. So I think one of the things is that the elements, as when the portal frames and the roof elements, the set's gone up, we put in these bays from the wall bays, again assembled on the ground and craned into position. The view of the inside of this is sort of fairly dramatic and gets more so. What's really nice in that top right-hand corner, you can see the purlins are really just a simple plywood I-beam. They've just got a simple block of timber at the end, which is actually mounted or already pre-mounted on the box beam portal frame, and they simply screw those on, and so those rafters just get screwed into place with the tech gun, and the purlins, get screwed into place with the tech gun on those little timber blocks. So it's really, really simple and really elegant way of assembling stuff with very, very little means. Centrally, this cross section through that portal and the purlins that come in. Extremely simple and elegant and very quick. Lots of screws. The view back to the that frame from the centre of town, as you approach town on top of the hill, you can see the rolling hills, and then the sort of the classic layout drawings of all the various different elements of the joist, the bearers, the stumps, the rafters.
We set on the grid on the basis of the accommodation that we knew that we were needing to provide, what appeared to be the most efficient way of managing that. And I guess the other thing that we wanted to emphasize is that there is a kind of discipline that you need to exercise if you're going to take full advantage of this this kind of building. A discipline in design to stay within to work within the grid and to actually adjust your grid so that it works effectively for you. It's an old modernist thing, but we've lost track of. I think.
The building challenges it in a few areas, but that's what happens when you crank a building.
Yeah.
And you can see the frame. These are the primary framing elements. So interestingly enough, the columns are made out of 3 pieces of alveole screwed together to form a chunkier section, about 130 by 135
on
the perimeter columns. And you can see
here. Yeah.
And you can see the curved nature of the veranda decks just simply being picked up with simple shortcut elements running through there. And on the left-hand side, that classic sort of stump to the bearer connection, which is very, very simple. The rafter, the veranda elements are actually, again, a cassette that are hoisted into position. This is a cross-section through the hall. You can see the retaining wall. Ventilation around the edge of that floor is really important. So there's these web forged grates running all the way between the retaining walls and the subfloor to make sure that we get good air movement through those areas.
And the other thing is that one of the things that we're very careful to do is to not allow anything that is in direct contact with the ground to be in direct contact with the timber superstructure. So those grates don't actually touch the timber. They're bracketed off the concrete ramp. And that's a detail which we apply all the way around the building. So these are the lightweight cassettes for the lower roofs on the veranda structure that drop over the 3-piece columns, which you can see a bit further on. And this just slides in here because the only piece of the building that was actually carpentered on site was this little garden screen at the back of the function centre, which you'll see slides of a bit later on. And there's the more conventional assembly drawings for that.
This is the images of the finished product shortly after completion. So the landscape is still in its very rudimentary state. Our work sort of stopped at the edge of the building, and the Shire picked up the roadworks and the landscape elements. So the slide on the right is the approach for pedestrians running through this wedge-shaped form, and on the left is the form transforms from a horizontal framing element looking back towards the town to a vertical element which is focused on the bounce in the centre of the oval, celebrating that great moment of Australian football in every game. And the yellow stringy bark cladding, which is just lightly oiled but will silver off as the building gets older.
The intention was that the timber will turn into essentially the same colour as the zinc aluminum upper wall lining as the building grows older.
You can see these big beams running through the centre of this area. Again, they're plywood box beams. They're quite thick, but they use that spacing of the monocoque shell that's formed by the beam sides to actually get efficiency rather than using mass.
They're also shaped so that they fit the curvature of the radius of that curved fan entry.
We're just losing a little bit of that comment, Patrick and Finn. Maybe just mindful of the microphone there. Yeah.
Okay. Sorry. Yep.
The building's been well loved by the community and by the community.
Yeah, we're just losing Finn.
Oh, they do everything from Christmas events through to weddings, school events, gatherings. It's an amazingly sort of well-used building. They do their Anzac ceremonies there. It's really given this single building that the whole of the town can gather around and use from a celebratory point of view. So it's been very effective and very well loved so far. This is the inside of the function centre. We reused the old basketball floor, which was Jarrah, and the men's shed remilled the Jarrah floorboards and created this beautiful sort of silky Jarrah colour to the bar into one of the function centres. This is the wonderful outdoor screened area that we spoke about before, this garden space that looks back towards to the west towards the town. And just various views. Again, screening these veranda areas so people can use them in the morning and the afternoon. On the inside of the sports hall, this is a fully sprung floor, and it's the full standard for basketball. So it's got our full heights. Again, the cooling is really only through those trademark big ass fans hanging from the roof, and then wet glass on the south side gives us lots of natural light, and these big sliding doors that allows us to open up and capture the breeze when we want it to do that. Behind these timber cassettes, which are radiator pine cassettes on the ceiling and the wall, it's sort of black recycled polyester bats, and that gives a really nice acoustic quality to the space. So the space is actually very quiet, and for a sports space, it's really fantastic. So it's really good for doing other functions and acoustic functions in that area because of the acoustic qualities of this acoustic wall we've almost created.
And this is the Anzac Day breakfast, I think.
That's right. Yeah. Anzac Day breakfast.
Big deal in country towns. They had upwards of 300 people there last year, I believe.
And again, the night view. The building's used a lot during night as well. So these night uses of the building makes it feel very romantic and very peaceful. Pleasant place to be in. You can see actually there's a little one of the funny objects poking out at the top of that sports hall is actually a commentator's box, which has broadcast capabilities, so they can broadcast games to the local TV network and view both the basketball and the oval from the same box.
And that section of deck that you saw in the last slide is the only section that isn't protected by veranda or some other covering. That was a late addition that we were asked to put in there by the Shire, and at that point it was too late to look into a way of protecting it. So this piece of deck will actually have to be maintained more rigorously than the rest, which is protected. So I guess one of the other things that we wanted to point out is that wherever we have used timber on the exterior, we've endeavoured to keep it protected. That's the last slide. So that it is somewhat protected from the weather. Where we can't avoid that, we simply use a heavier gauge timber to allow it to do what timber does when it's subjected to the kind of climate that we're in. So it'll fluff up, we'll get some surface checking in it, but we've got plenty of depth and volume of timber there to ensure that its durability is maintained. And
this is the last image. This is a long dinner that they've had in front of the function centre. We're building out the building 2,800 square metres. I think
actually 3,700.
We've done it. Oh yeah, that was the enclosed area. So 3,700 including the verandas, and the largest timber building built in Western Australia. Too.
Just losing Finn there.
That's a nice thing to have done. We might share this back to you and open up for questions, perhaps.
I noticed somebody there is asking about why stainless pins on the locating pins on the tops of the columns, primarily to ensure that we don't get any degradation of that through any oils or resins in the timber. Simon, Doris, yeah, we won an award, the Sustainability Award at the World Architecture Festival in Amsterdam last year, and we were finalists in the sports category awards. We've also won the Architizer A+ awards for community buildings. Community buildings, and we were chosen as one of the 6 honorees out of all of the buildings submitted for the Architizer Awards. That's a New York-based organisation.
Okay, look, we did have some other questions there. One was just asking about just basically a question mark on the budget. And if perhaps that comparison, if it was with a maybe a more traditional construction practice.
Yeah, I mean, what was interesting is we worked very closely with Timberbuilt during the design phase to work out what the elemental costs of that might be. And at the same time, our quantity surveyor was comparing it with conventional construction. And we actually came in pretty much at the same price as doing it as a conventional steel frame construction. It worked out almost identical. So in terms of our analysis after the event, it comes up being as the same cost. Obviously, when we're doing with experimental stuff like this, de-risking the logistics, for instance, of getting timber across Australia and core structural elements from New Zealand had to be managed, but that still came within the budget. I think largely also because we had a cooperative builder. It was publicly tendered, and the contractor who won it was Syme Constructions, and they're fantastic carpentry-based builders from Esperance originally, and they now work across the southwest. And I think because of their confidence and also the confidence in both the architectural team, but also Timberbuilt's wonderful, shop detailing and constructability, they were really confident in putting it together. So that's that really helped. But the spread of tenders were actually very close, so there wasn't a huge amount of spread in tenders. So it seemed to be that good documentation helped de-risk a lot of that kind of perceived risk of doing an alternative construction system.
Might be worth mentioning that we did have a non-conforming tender submitted, which was over $1 million more, if I remember rightly.
Yeah, I think someone wanted to do it out of steel and precast concrete, and that was about $1 million more than than the tenders, the rest of the pool.
Yeah,
I mean, the final cost, I think we can disclose the final cost was everything included, 9.1 million.
Okay. And there was a pickup there that why is both cost and durability sort of flagged in both the pros and the cons?
Well, one of the misunderstood parts about building in timber is durability. We have a durability index for timber, which I feel is pretty out of date because it's based on burying timber in the ground and seeing how long it takes to decay. I think it's foolish to do that. So durability is actually about how you detail your timber rather than the nature of the material itself. So overall, we need to do a lot of work to relearn that, I think, certainly in this part of Australia, and generally around the world. You see some pretty sloppy stuff happening. And the other point, Greg, I'm lost for a minute. What was durability and
durability and cost?
I think those two columns of the pros and cons was more of a perception thing. So in fact, the cons column, the questions about the challenges to timber applications were very much perceptions of timber. There's problems with termites, there's problems with durability, there's problems with fire, and they're actually not problems, they're just perceived problems. In fact, if we do our job properly in terms of detailing and understanding the application of the timber selection and how it's milled and how it's actually put together and how it's designed to be used, you overcome all of those things.
But it is something that you have to deal with your clients.
And explain it,
all the time.
And what was the, what got it across the line from the point of view of the Shire Council there wanting to accepting a timber solution versus perhaps
first of all, they did actually
plan.
want something that was different to what other shires were doing. I mean, there's a lot of big tin boxes out there. What really put it across the line, though, was that trip that I took them on to Melbourne, where we trotted around a number of, I can't say similar buildings, but buildings of a similar scale, and then finally went to the timber built factory and saw the timber being milled and saw the kind of precision that could be achieved, and that was really the seal on the deal, if you like. So being able to show them the whole process from if you like, the finished object back through to how it's fabricated was pretty important. I mean, these people are all good hands-on rural population. They're used to understanding how things work.
Yeah.
I think it demonstrates the need to have exemplar buildings to show to people. So now that we've got something that is of this scale and is all timber, hopefully that will encourage other clients to have a look at it and to feel confident in doing that selection. And until they've got examples, it's really tricky for people to understand what's possible.
And I guess, Finn and I were constantly getting questions through the process from our other consultants, sort of, are you sure we're going to have enough room here? Have you left enough room for our ducks to go through there? And they said, yes, it's exactly what you asked for. So getting even the rest of the design team to understand the level of precision that we're operating at was needed reinforcing, constant reinforcing.
Yeah. Earthquake consideration. It's in an earthquake zone. Maybe comment on the performance of the building in consideration of earthquake.
Well, I can't say very much about that, except that obviously it's a very lightweight building, and I guess all of the connections have been designed to take that into account. But that would really be a bit more specialised of a question than I can answer, and needs to go to our structural engineers.
Yeah.
That it is stiff, though. So I suppose the two philosophies of earthquake design. One is a stiff building, and one is a building that can move. The portal frames and the assemblies are actually quite stiff. So you've got a low inertia building that is very rigid in those joints. So it moves as one rather than a flexible building like a high rise, which the bottom and the top can move out of alignment. So because we've got a very, very low mass building, it can move very easily as a single stiff object during an earthquake event.
Yeah.
There was a question here, just with the use of your other design consultants and the interface with Rhino. You would better understand that than me. Yeah.
Look, I mean, so Rhino was used as a kind of a modelling tool. Revit was our documentation package. So what we often, Revit is a wonderful tool for drawing, although we're all held under its draconian licensing laws. I like to mention that to Revit people, how they're all holding us to ransom. Anyway, but we use Rhino to model because it's a much more flexible modelling tool from a design perspective. That gets exported into into Revit. And then the Revit then talks to the CADWorks software directly. They can pull the Revit model straight into the milling software without really doing anything to it.
I mean, that's certainly current process. When on this building, we were a bit back to front because we couldn't at that time embed the Rhino model in a Revit model. So that's now much more streamlined, but either model type can go directly into the CADWorks system and retain dimensional accuracy.
Yep. Okay. Okay. I'm not sure if any other. I'm not seeing the actual Zoom screen, so I don't know if there's any other questions that you can see that have come up on there, Patrick.
There was a question about internal finishes. We've got two finish types in the building, haven't we? So I'm assuming the finishing, we used oils basically. We've used some internal and external oils, slightly different.
The internally, primarily, it's a 50% tung oil, 50% citrus oil mix. The citrus gives the tung oil a better finishing smell. But interestingly, it also turned that recycled jarrah dark, very dark. Dark red to black. Almost.
Yeah, like a velvet, black velvet.
which we quite like.
Yeah. And externally, seeing the building, it looked like it had a little bit of sort of a stain in the.
No, it's just a dun clear decking oil. That's
right.
Right. Yeah. And in fact, it was the external cladding wasn't meant to get oiled. It just there was a misunderstanding somewhere along the line, and it did get a couple of coats. The Shire really has the option now of either maintaining it, so keeping that kind of beautiful honey yellow colour, or allowing it to go grey as we originally intended.
Yep. And what's your feel about other projects of similar nature being taken up in this market?
I think there's a great deal of, well, there's been a real flurry of interest in the last year, I think we could say, of this kind of construction. This little building seems to have stirred up quite a lot of interest around here and elsewhere, and I think generally people are getting more better informed and more interested in timber, engineered timber construction generally.
Yes, yeah. And we're seeing that in a number of projects that are unfolding in this market, which is really good. That regional opportunity is, I would imagine, quite unique, and it's a great outcome. Yeah.
Greg, there was a question from Alan Lamb. He noticed that there were no gutters, and what's our project approach to water recycling? It's probably an important question. The main roofs actually have siphonic drainage on them, so there's a siphonic gutter system on the really big buildings, and then the eaves of the verandas are ungutted, and that water shoots off the edge and lands past the edge of the veranda. And with the water that comes off the roof, it goes into the stormwater drainage system across the oval. The oval water and the stormwater off the building is collected and transferred into the Shire's wastewater treatment plant. So they collect all the runoff off the oval downhill and then pump it back up. They treat it and pump it back up on the oval for irrigating the oval. So that's kind of a core stormwater collection system that the Shire uses across all their roads as a way of irrigating an oval, because obviously lawns are thirsty things. And it's important that we keep the ground around the edge of the building as dry as possible, so that the main catchment areas are in fact the big roofs.
Yep. Have you got one last question there that you can pick up on?
I'm just flicking through those. How much additional, there's a question from Samuel saying how much of additional percentage of the prefabricated timber elements were allocated for error or for mistakes on site? The answer is none. The prefabricated elements, Timberbuild, Bruce Hutchins from Timberbuild, who is a fantastic timber engineer, gets quite offended if I suggest that it's as accurate as IKEA. He says it's far more accurate than IKEA. There is no wastage, there is no errors, and there are no bits that are too small or missing. And he's absolutely right. There was no mistakes from all those elements that came to site. So The only corrections really needed to come when some elements were left out in the weather and they swelled slightly in the end. If they got rain on some of those tongue and groove, on the end grain of the LVL, where you get a routed end grain. But other than that, there wasn't any need for them to have any additional spares. If there was something that was really damaged, they could remake it and remill it.
It's certainly a fairly low rainfall area, so moisture protection of timber components not an issue.
Well, look, it is, because I mean it just happened to be that the winter that we were building in was the wettest winter that we've had for a decade, which is pretty ironic, really. But anyway, that was it. I think that look, you always have to figure that. You always have to design for the likelihood that you are going to have a wet period, a wet winter, and we know that timber of any kind, doesn't like having its environment changed. So it doesn't like being in water for a while and then being dry for a while. It would rather stay essentially in the same climate, same sort of situation. So you design for that.
Yeah. Well, look, gentlemen, we'll leave it at that. Look, both Patrick and Finn, thank you very much for your presentation. I can see from the comments and chat that it's been, very positively responded to, and it's created quite a bit of interest. And so, again, thank you very much. We're just going to move forward then. Again, just for anybody who requires the CPD certificate and respond with there's the CPD question. So I'm going to hold that screen just for a moment if you want to take a snapshot. So I'm just going to move on now and just remind you that we've got an exceptional WoodSolutions website and access to exceptional data, including over 50 timber design guides. I've just picked up on a few there that are relevant to our topic today. And these are a very in-depth detail into each of these different topical areas and the huge list of those available to you. So go to the woodsolutions.com.au website. And of course, I think the Pingelly Recreation Centre is featured there, along with a lot of other case studies and projects, both nationally and internationally. So take up that opportunity. A recent introduction or initiative undertaken by WoodSolutions is a series of videos available through YouTube and off the WoodSolutions website. So taking you behind the scenes in things like timber manufacture, design, construction practices. So a really good in focus topic for you to consider as well. Next week, next Tuesday, we've avoided Tuesday this week with the Melbourne Cup in Australia and the holiday over East. So it will be back to Tuesday, the 10th of November next week, with the topic of the effectiveness of fire safety systems in residential buildings, presented by Len Garris from the Centre for Social Data Insights and Innovation Statistics in Canada. So with that, thank you everybody for attending. Thank you again to Patrick and Finn for a terrific presentation, and certainly join the WoodSolutions webinars next week. Thanks very much.